Hello, everyone. Welcome. Thank you for joining us this evening at this Mixed Reality Developer Forum. Before we begin, please check in on today's event. The check-in link is on the screen, or you can scan the QR code, which will take you directly to the check-in page. The event ID you need to enter is 14497. Remember, by checking in, you get access to all the resources and learning parts after the event. The check-in information will also be added to the chats. My name is Rav, and I'm the Program Manager at Reactor London. You can find all our upcoming events on the Microsoft Reactor website. Before we begin, please take a moment to read our code of conduct. We are all here to learn, so please be respectful of other people's views, understanding of differences, and be kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Today, we are joined by some absolutely amazing team working in the mixed reality capacity who have helped us out to put this event. Our first speaker is Karim, Metaverse Lead for Microsoft UK, who will be leading the session. Hi, Alex.
Hey, thanks for having me.
Over to you now.
Awesome, cool. Welcome to this Mixed Reality Developer Forum. It's been in the works for a few months, and I'm really happy to bring a mixed reality developer event via the Microsoft Reactor UK today. So, as mentioned, my name's Karim. I'm the Metaverse Lead for Microsoft UK, and I figured I would just go through the agenda for today. So, in terms of Sorry, I think there's some building work going on next to me. Apologies if that's coming through. So in terms of the agenda that we've got today, we've got four kind of key topics and things that we want to discuss. So the first is an introduction to mixed reality, which I'll do. I think it's always important with events like this to make sure that everyone is up to speed and on a level playing field regarding what the technology is. We've then got April Speight doing a conversation on XR development fundamentals. So once you understand a little bit about what the technology is, we'll then go into what the development fundamentals are. How do you guys get started? I think that's a really important point to cover. And then on our next step, we've got Oscar joining us to talk about touching holograms, a little bit about the story of advanced interactions using mixed reality, which I'm really excited to bring to you today. And then we'll talk about what the next steps are for getting started in this space, and then do a little bit of a Q&A with all the speakers on the session. So I think it's always good as well to talk about yourself, and do a little bit of an intro. So if we go from left to right, first kind of picture I've got here is me as an Arsenal fan, which is always a bone of contention whether you mention your allegiances on a live session. But I'm an Arsenal fan, but during the pandemic, obviously wasn't able to watch any of the games live. So instead of going to the stadium, what I was able to do was actually visit the stadium virtually through virtual reality. So you can see here, I'm watching a game live, an Arsenal football game live through the power of virtual reality. I'm actually physically or digitally sat in the Emirates Stadium, but watching the game live through virtual reality. Then next, we've got a picture of my professional life. So previous to Microsoft, I actually worked at McLaren. So at McLaren, I was able to bring mixed reality technology into the organization, so both in Formula One and in automotive. And that's where my kind of, personal passions for this technology and professional lives kind of collided, as it were. And that's led me to my position today at Microsoft as Metaverse Lead for UK. So, and then the final picture is a picture of me recently at COP26. I was able to join the Microsoft stand there and provide metaverse mixed reality experiences on the stand. So that was a really cool experience, and as you can see from the picture, I met Nico Rosberg, Formula One champion. So that's my new claim to fame that I always drop into pretty much every conversation that I can, because it's cool. At least I think so. Maybe not everyone does. So what is mixed reality? I think that's a really key point to mention, because you might have heard lots of different kind of words and terms. Well, From a Microsoft perspective, mixed reality is really blending the physical and the digital world together. So, the physical world is the room that you find yourselves in right now. It's the physical world that we interact with. The digital world being all the digital content that we work with, whether that's 3D content, Word documents, PDF documents, all of that digital content. And mixed reality is really about blending the two together. And Satya Nadella recently mentioned, the metaverse, as it were, is embedding computing into the real world and embedding the real world into computing, which I really liked as a phrase, as a way of kind of discussing this technology. What I've got here is kind of a few GIFs or GIFs, depending on which term you prefer, to kind of go through a few of the terms that, and I find this is really kind of a good visual way of getting your head around some of the kind of immersive technology. So when we talk about virtual reality, it's really about closing you off from your current environment, right? Transporting you somewhere completely new in a digital way. And so you can see the picture on the left is someone wearing a HP Reverb G2 VR headset, a Windows mixed reality headset, which is really cool. And then on the right, we've got a really cool video game, which I really enjoy, called Superhot. But as you can see from this experience, that you are fully transported and digitally into this environment, right? You no longer can see the real world, as it were, and you're fully immersed in that environment. Now, for certain scenarios and for gaming specifically, really, really amazing. And you feel like you're part of it, right? You see these people attacking you, and you've got to use, whatever you can find, like a mug or an ashtray, to try to defend yourself. But yeah, that is such a much more exciting experience, being fully immersed in your environment. So that's virtual reality, as it were. So augmented reality is really about the first step of bringing digital content into the real world. And the examples I like to kind of discuss when talking about augmented reality is mobile phone apps, right? Everyone, most people have access to a smartphone these days. And as you can see from the picture on the left, the current set of iPhones and Apple devices have really amazing LiDAR sensors built in the back. So what you're able to do then is, through the phone is able to map out the real environment. And then once the real environment is mapped out, you're able to place digital content within it. And a good example of a solution here is the IKEA Place app. So if you're ever buying a piece of IKEA furniture, what you're able to do is use the IKEA app to visualize it in augmented reality in the place that you are. So, for example, if you're looking at getting a new bed or a new piece of a new sofa or something like that, you're able to then use your phone to see it in one-to-one scale in the environment of where it would be, and so that's augmented reality. Mixed reality is really the next step, as it were, of bringing digital content into the real world. It's using headsets such as the HoloLens 2, you can see on the left, and it's bringing digital content in a way that is much more immersive. So as you can see in this image on the right, is that it's not just bringing the 3D content into the space, it's also overlaying it over the motorbike in this instance. It's that full understanding of just bringing digital and physical content together and blending your reality, as it were. So that's really mixed reality. And the metaverse, right? What's the metaverse? This my recent rebrand as metaverse lead for UK. What does that mean? What is the metaverse? I get this question quite a lot. The metaverse isn't just mixed reality. It's really about a stack of services and solutions to building digital and physical blended experiences. Now, a lot of the core fundamentals of being able to interact in 3D and bring content into the real world is through devices like the HoloLens and platforms like Microsoft Mesh and mixed reality. But there are also other sets of services that I look after, such as digital twins and Azure IoT, and bringing in digital representations of physical real world places through platforms like IoT and digital twins is a really core kind of piece of the metaverse, as it were, or the way that we see it. So yeah, that's the metaverse as Microsoft sees it, and we're really excited to kind of continue the conversation. And I mentioned Microsoft Mesh just there on when we're talking about the metaverse and the future of kind of 3D immersive collaboration. And I've got a really cool video that I'd like to play at this point, regarding Microsoft Mesh, and so I'm just going to say cue the VT, play the video if that's all right.
Connection is a spark that gives our lives meaning. It drives us to seek out others who feel the same way.
Okay, why don't you input the data and we'll take a look together. Hey Mari, what you got for me?
To find those who share our views, yet offer different perspectives.
Look over here.
Challenge us with new ways of seeing.
That I think we should.
Deepen our understanding. And enrich our lives.
最后一笔的时候，往前。
Great things happen when we commit to something bigger than ourselves.
Let's take a closer look at it.
Place this here. Let's see how we go from there, okay?
This sense of collaboration and the feelings of connection it brings excites us.
Hey, just in time.
I'm gonna move it slightly, okay?
It's yours, take it.
We have 2 planes right now on the same trajectory.
As we put people first, technology fades into the background and feels like anything but.
Aisha, what do you think?
I think if we had 330, maintaining 2800,
We'll be clear for approach.
Excellent.
This changes the way we see the world, and in turn, changes the world we see.
These numbers are looking great, actually.
There's promise in the possibilities, and what we see and create next will stretch the imagination.
Good morning, Sarah.
Morning.
Slowly coming towards the thumb.
A world without boundaries,
Good job. A lot better than yesterday.
Yeah.
Excellent. Slowly bring the
a
arm
world
down.
where technology enhances, not limits, humanity. With people front, center, and in the spotlight. The future is here, and here can be anywhere. Introducing Microsoft Mesh.
Awesome. So yeah, that video always kind of just inspires me, and it really excites me when I think about mixed reality. And like I mentioned, this is very much a passion of mine. And I'm really excited to be able to do this every day and talk about mixed reality, which is super cool. And Microsoft Mesh, here can be anywhere, as it were. Being able to actually interact with people in 3D and bring people, digitally into your environment. And I think the key thing to note when we talk about Microsoft Mesh is there's kind of 3 core pillars to that platform. The key one being that from my perspective is the feeling of presence, right? We're on a live stream, we're in 2D, we're interacting day to day using platforms like Microsoft Teams. It's very difficult to build up genuine relationships in 2D. Humans are inherently a 3D creature. We interact in 3D. That's the way that we perceive the world. And so limiting ourselves through a 2D screen is a challenge, right? And in this kind of hybrid world that we spend a lot of our time, it's not a way that I see really working long term for us. So in those scenarios where we can't be together physically, it's so much better to be able to have that feeling of presence and look someone in the eye and hand someone something digitally. Really amazing. So yeah, that feeling of presence is really core to everything. The ability to experience together is another core pillar of Microsoft Mesh. Having content in 3D, be able to hand it to each other, annotate on it, work on it together. It's really core. And then the other one is the connect from anywhere, from any device. We don't want to limit this kind of experience to devices like the HoloLens or VR headsets, but being able to join from other devices, Windows 10, etc. And that's a key core principle, is that no matter what device you're using, that you're able to still take part in the experience. And if I go on to mixed reality as a stack of services, I think it's always key to kind of talk through a few of the core ones that are relevant. At the top, at the first point, we need to talk about the devices, the end point, as it were. Now there's a array of intelligent devices, Windows, mixed reality, or the HoloLens, HoloLens 2. You can see a couple of images at the top. Also mobile devices, iOS, Android, various devices, but they're really the end point. the power and what we're talking about today is really developing and building solutions. And the key things, on the developer tools and programs is the Mixed Reality Toolkit, which is a really amazing Microsoft-driven project to accelerate, mixed reality development. April will be talking about that in a lot more detail, which I'm really excited about. We also have a partner ecosystem for those that build mixed reality applications for other businesses to consume. And then there's 3 kind of core Azure services that really are the backbone of a lot of our kind of applications in this space: spatial anchors, remote rendering, and object anchors. And what I'll do at this point is just kind of give a brief kind of overview of the 3 services from Azure and their context and why they're important in a mixed reality setting. So we talk about remote rendering. We talk about the intelligent devices on the previous slide, such as the HoloLens 2 or a mobile device. A mobile device or a HoloLens has only a certain amount of graphics computing on board, right? It's a wireless experience. It's not connected to a high-powered gaming PC, for example. That can be a limitation when you start bringing in very high-fidelity 3D content. So what do you do? Do you decimate the 3D asset so that it no longer has all of the cool intricacies? No, ideally you don't do that because that really limits your experience. But what you're able to do using a remote rendering is to use effectively that high GPU graphics power in the cloud in Azure and stream the content down to the device. So that's remote rendering in a nutshell, and a really exciting kind of product set, and it really supports experiences on devices like the HoloLens or mobile devices on iOS. So it's something to think about. Spatial anchors is kind of grouped with object anchors, and it's 2 kind of ways of looking at things. So spatial anchors is thinking about, right, well, in a certain area, geolocation, I want there to be digital content, for example. So you can see in this image that these kind of frontline workers are in some sort of factory setting. And when they go over to a certain piece of equipment, they want to see the live IoT data for that, that piece of equipment. Now, that piece of equipment is a large piece of equipment and it never moves. It's always in exactly the same place. Well, what you want to do is have a service that helps you anchor digital content to that location that is always static. And so that's where the spatial anchor service comes in. It's spatially aware mixed reality experiences, and if you want to build those kind of experiences and you want to put certain content in certain places, it's always worth having a look at that, and that's spatial anchors. Now, in the scenario where the digital location doesn't always, the physical location doesn't always the same, for example, but you want digital content overlaid in context to a piece of equipment, or what you want to do is you want to use object anchors, which is coming in preview. And what that does is when you look at a piece of equipment, it understands it and then puts the digital content over the top of it effectively. Instead of it being anchored to an XYZ coordinate, as it were, geolocation, it's anchored to the actual physical piece of hardware, for example. So that's object anchors, and that gives you a kind of a high level overview of the 3 Azure services in the mixed reality stack. And then, the final, kind of slide I just wanted to cover is obviously mixed reality devices such as the HoloLens 2 and the different kind of SKUs that, that you might be interested in. I think the key one to call out is, we're on a developer event is the HoloLens 2 Developer Edition. And I think if you are interested in getting into HoloLens 2, it's a great offer to have a look into. It comes with $500 of Azure credits to get started with some of the services that we've kind of talked about regarding spatial anchors, object anchors, and things like that. And it's specifically built for development use only. So yeah, something to think about if you're interested in getting into this space and you're interested in HoloLens 2. So that's really all the content I really wanted to cover today. I'm really excited at this point to bring in April as our kind of next speaker. I think the key thing to just note on the slide, I've got a QR code to my LinkedIn, which is sadly the only social media that I really use. I know Adam, who's also on the call, was looking for my Twitter handle. I don't have one, so yeah, that's my LinkedIn. And yeah, I guess at this point I'd like to bring in April Speight, who's the spatial computing cloud advocacy lead, which can be a handful. So April, I'm going to hand over to you at this point.
Yes, thank you. I really appreciate it. Hey, everyone. So as mentioned, I'm here to cover the XR development fundamentals. And so my name is April Speight. I do lead our cloud advocacy spatial computing team here at Microsoft. And our team, we're focused on advocating on behalf and to technical communities. And in our case, it's the overarching extended reality community. So among the various things that we do, one of our major priorities is onboarding new developers, such as yourselves, into XR development. So given that there's so many options for you all with regards to getting started, what I'm going to do is provide a lay of the land across the industry, but I do want to let you know that because there are so many different options, this is not going to be an exhaustive list of all the ways that you can get started. Rather, these are approaches that we've identified as the most commonly used in the community, as well as what Microsoft has to offer. So with that said, let's head into the slides and let's start with the agenda for today. So I'm going to start by sharing some design principles that should be considered for each and every app or experience that you create. It's a very important part of the process. Next, we're going to explore some engine options, frameworks, toolkits, and APIs available for development. And then from there, we'll start to get a bit more niche and focus on how you can get started with developing using Unity and the Mixed Reality Toolkit. I'm going to share with you how you can do so for both AR as well as VR. And then finally, we'll check out StereoKit as another option for creating apps. Resources will be provided at the end of the session alongside my contact information if you'd like to get in touch. So without further ado, we are going to begin. So when it comes to designing for a mixed reality experience, you'll want to take the following principles into account. So first, there's comfort. Now, this may be more applicable to head-mounted devices, which are devices that you physically wear on your head or in your face, for example, if you have on smart glasses. You'll want to ensure that the objects are not being placed too close to the user. And then there's also scale. So displaying 3D models at their appropriate scale, it can give a sense of realism. So in this example that's on the screen here, there is a vehicle. So rather than display the vehicle at a teeny tiny little model version of it, this is actually going to be at full scale. And then in addition, there's typography, and that plays a big role, especially with for folks that have low vision. You'll want to ensure that any text that's being displayed is legible, and it also utilizes accessible colors, which naturally leads me into color, light, and materials. So all these factors are going to come together to help display what someone sees when 3D models and images and text are going to be rendered. So consider the light conditions, such as it being either super bright or too dark, and the impact on how that will affect the objects that are going to be displayed. Next, we have sound. And so sound, it not only enhances our experience, but it can also provide auditory cues, such as playing noise when someone selects an object, for example, or pushes a button. From an accessibility perspective, you'll just want to ensure that you're also including captions as an alternative for those who are hearing impaired or hard of hearing, such as myself. And then finally, there's interaction models. And so there's various ways available to interact with AR and VR apps and experiences that goes beyond using our hands. And there's going to be voice commands, for example. There's head gaze. There's going to be eye gaze as well. And you can also use controllers. And I've even seen at the MIT Reality Hack, there is a device where you can use mind control, which is going to be made possible with brain to computer interface. So despite the options available, what you'll want to ensure is that you're selecting the interaction model that's appropriate for your app or your experience. And most important, don't forget about those who have physical disabilities and how your app or experience may negatively impact their personal experience if what you create isn't accessible. All right, engines. I only have the top 3 that's used across the industry listed here. First being Unity, that's going to use C# for scripting. Next, there's Unreal, in which you can use C++. Unreal also has Blueprints, which provides you the alternative of visual scripting. I heard that Unity has something similar at the moment as well. And then finally, there's Babylon.js, and that's going to use JavaScript. And so how do you choose your engine? Just like devices, it is a matter of personal preference. And I will say that Unity and Unreal does require software installations, whereas Babylon.js is going to require that you have an editor, for example. As for frameworks, listed here, I have the Universal Windows Platform, in which we're fans of here at Microsoft. Next, there's going to be ARKit from the folks over at Apple, and then we have Arcore from the folks over at Google. And there's also a variety of toolkits as well available that can help accelerate your development. So we'll be exploring Unity more in the next couple of slides. So I'm going to focus on Unity for now. Unity has what's called the Unity XR Interaction Toolkit. So this particular toolkit provides cross-platform support, XR controller input, I should say, which is useful for interacting with your apps. And then there's also the Mixed Reality Toolkit, and it's our very own toolkit that we have here at Microsoft. MRTK for short. It has cross-platform input system and building blocks for spatial interactions and UI. And so since we'll be using the Mixed Reality Toolkit for our upcoming demos, I will dive into what the toolkit provides. So as mentioned, Mixed Reality Toolkit does provide cross-platform support. That means you can use MRTK for apps that target the HoloLens, VR devices, OpenVR platform, and mobile, so your iOS and your Android devices. In addition, there are 2 toolkits actually available. There's one for Unity, and then there's also one for Unreal. So the Mixed Reality Toolkit packages, along with Mixed Reality packages in general that we have, are available in what's called the Mixed Reality Feature Tool. So on the right side of my screen is where I have a screenshot of what that tool looks like. It's a standalone tool, and it's where you can discover and update and add Mixed Reality feature packages into your Unity projects. You can select the packages that you need. You can view the dependencies as well as the proposed changes to the project's manifest file. And once you're all set, the tool imports the packages into your Unity project. Now, this tool is going to be necessary if you're using the Mixed Reality OpenXR plugin, which we encourage you to utilize, or if you're importing the Mixed Reality Toolkit into your project. The reason being is that you can find both of those packages within the tool. Do note that this is going to be, at the moment, only available for Unity. Okay, we're going to get into some demos. I'll be sharing with you some beginner-friendly examples of how you can start your own mixed reality development in Unity using the Mixed Reality Toolkit, HoloLens, and we're also going to go through what you can do to deploy to a Quest for VR. So I just want to quickly give you a tour of the Unity interface in case you've never used Unity before. So starting off here in the middle top, we have the scene panel. So the scene panel displays all of the objects that are in your scene, if you will, such as your 3D models, your images, your text, what have you, that'll actually be what people will see or interact with in the app. Next, on the top left, we have the hierarchy panel. And this panel, it's going to list all of the objects that are in your scene. Followed by that, on the far right, we have the inspector. So if you were to select an object in that hierarchy panel that I just spoke about, the panel that's that inspector one on the right, it's going to list, it's going to provide the object's properties or the information about the object. Next, we have the game panel below, and it displays what the camera sees. And so anytime you test your app out, you're able to view what the camera sees in that game panel, which is really helpful because then you don't always have to necessarily deploy your app to your device. You have a chance to be able to see it in there, test things out. And if you also don't happen to have a HoloLens, for example, you can try that out there. That's often what I do. And then finally, at the bottom left, we have the project panel. So this panel is where you can find all of your project assets, such as your scenes, materials, scripts, packages, etc. It'll all be down in there. As you import packages, for example, let's say the Mixed Reality Toolkit into your project, you'll be able to find that there as well. And you'll be able to find that in the packages section. Okay, so project setup. There's a number of settings that'll need to be set before you begin. And for HoloLens, since I'll be talking about HoloLens, you'll need to select the Universal Windows platform for your build. If you're targeting, let's say, an iPhone or an Android device, you choose the appropriate platform. So iPhone's going to be iOS, Android is going to be Android. And then from there, you're going to use the Mixed Reality feature tool to import the Mixed Reality Toolkit. And that's also where you can get the Mixed Reality OpenXR plugin as well. That OpenXR plugin is going to provide you with cross-platform support, so that way you can create a code once, deploy to many. Once you have those packages installed, there are XR plugin management settings that'll need to be set. And I have that on the right side of the screen here, such as the depth submission mode at 16-bit, as well as the interaction profile. And once your project is set up, you're ready to begin. So I mentioned MRTK. It's equipped with a variety of features to help accelerate your mixed reality development. So one such feature is the ability to add hand manipulation. You can add manipulation using the object manipulator script. You'll find Mixed Reality Toolkit has a lot of helpful scripts. But this one in particular, you can use that if you're going to manipulate. Manipulate being grabbing, for example, expanding, if you will, rotating. Those are what we identify as manipulations. And so if you pair this particular script with our near interaction grabbable script, you can then grab objects at a close distance rather than far away. But it is helpful, though, if you're able to grab from far away, because if you want to create, as you should be, accessible apps, you are able to help those who may not be able to physically move and grab objects. They can be stationary where they are and they can still grab. We have like a tether right now, for example, in what I'm going to display as the quick video on the right. So here, as I have on the right side of my screen, this hand, this is all done in Unity. It is interacting with this particular object. And so both of the scripts is what's making that happen. And there's a variety of settings available that you can modify that will change or make these certain manipulations a little more specific. So if I wanted to restrict scaling, for example, which is making the object different sizes, I can restrict that. So that way, all you can do is just grab the object, for example. You can also restrict the ability to manipulate with just one hand instead of two hands. Right now, even though I have one hand up in the screen, I can actually grab with my left hand as well and move it around. All right. So next, we have buttons, and the Mixed Reality Toolkit, there's a variety of button prefabs, which are going to be objects that have preset configurations available that you can plop right into your app. So whether you want to use the prefab provided, or you can create your own, MRTK can help you out with that. So what I'm going to demo next is a prototype of a remote control car. Prototype, not perfect, just a prototype. For example, for simplicity, the car will be represented by a blue cube, and the controller that I have on the right side of my screen here was made using the MRTK pressable button HoloLens 2 prefabs. So creating the controller itself, it took very few steps. Using MRTK button prefabs, I was able to add the buttons onto a surface and then assign an action to occur on the button press. And so the action itself, very short script that moves the cube left, right, forward, or back. If you were to create this in a real world situation, you'd want to make the script a little more involved than the way that I've set it up. But right now it's just moving forward, backwards, left, and right. In addition, I was able to organize these buttons into a singular row using the Mixed Reality Grid Object Collection script. And that script is going to be used to organize objects into a grid with a specified equal distance from one another. So right now, my controller, the top row, is going to be a separate set of objects than what I have in the bottom row. But essentially, I create the button once, I duplicate, I apply grid object collection script, I have perfectly spaced objects. You don't have to just use it for buttons. You can use it for really any object that you'd want to use. You might have to play with it a little bit to adjust the settings. And so you can just get an idea of what that button press looks like. It's like pressing a button. Plop it down. There happens to be a sound that plays. You can't hear it right now, but that's more or less what it's like. So let's view me creating that in real time. So starting on the left, I create an empty game object that's going to be the parent for the controller itself. I'm going to just place everything in there. So once I have that created, adding in a cube, that's going to be my controller. I'm going to change the size of that. I'm going to make it significantly smaller. I'm going to make it a little thinner as well because controllers aren't massive. They're going to be smaller. And then from there, I am going to create another empty game object. This one's going to be the buttons. I'm going to house them all in there. So starting off, I like to create just one starting with. So I did use a pressable button HoloLens 2, adjusting where it's actually flushed against the controller, sizing it up because it was very, very small. And then from there, I am going to adjust what we have down here is in our button config helper script. I'm going to get rid of the main label, the see it, say it, just for these purposes. That see it, say it's actually really helpful so folks know that that way they can actually speak to and trigger something. Duplicated it because now I have my one button set up. Instead of recreating each one individually, duplicate, add the grid object collection script here that I mentioned, click update once I have my rows, and I have a row. Now, of course, they are too far apart. So all I'm going to do from here, I'm going to actually bring them up a little more because they are a little too far back from the controller. Turn my view back around. I'm going to adjust the width and the height here, and then update collection again. Keep playing with it a bit until it gets to a point where it's pretty much where I'd like. That might take you a little bit of time, but I think this is beautiful here. I have my controller, and I can, since I group them all together, I can move them up and down as I'd like. I can also rescale them as well. But in general, that part of the controller is created. I can press the button, the buttons themselves. They already have that interactivity built into it. And from here, if I wanted, honestly, I could add more buttons and just update that object collection script, the grid object collection script. I didn't get into putting in like the labels here for this example, but essentially what I'm trying to get at is creating prototypes. It takes very little with the MRTK. At this point, I didn't even open Visual Studio to code anything. All I did was drag and drop, clicked a couple buttons, and I had the beginning of a controller. So keep that in mind, especially if you want to do something quick. Maybe coding's not your thing, for example. Using what's in MRTK is really helpful, but as always, even though we provide you with prefabs, you can customize them to be even more what you would like to create for your app or experience. So if I were to give, let's skip ahead. Come on, PowerPoint. There we go. So if I were to give this app a try as is, the moment that the scene starts, the cube's going to fall into the nothingness of the virtual floor. So what's great about mixed reality is that digital objects can interact with the real world. And a big proponent of that, however, is the power to, or the ability, not the power, but the ability to create an app that's spatially aware. And so MRTK does have a spatial awareness system, and it can be enabled to help solve this. And so creating a spatially aware app with Mixed Reality Toolkit, it requires both the spatial awareness system is enabled and that a spatial observer is provided. Again, you can do some more customizations. You can change the color of the mesh. What I have on the right side of the screen here is the mesh that's going to be seen in your space as you're doing your mapping. One thing that I do want to call out is that first and foremost, the mesh is super helpful because it enables the person that's using the app to get an idea of what has been meshed. So that mesh is going to start kind of hugging the walls, the floors, objects that you have. It's a really good visual cue. However, once the mapping has been complete, I would suggest that you provide a way to hide that mesh before whoever is trying the app actually starts interacting with their scene. Why do you want to hide it? It gets distracting. It's great when you're doing the mapping, but when you're ready to start actually using the app, it's everywhere. And so it can make it a little more difficult to actually view what you should be interacting with. So the example on the right side, this is what it looks like as I was mapping my actual office. I even have a hide mesh button here to hide it. Another great thing about once you have mapped your space, if you're using a HoloLens, for example, is that you can save that to the mapping to your device, and then you can load that for other apps that you're creating. However, I will say that, I just lost my train of thought, honestly. You can save it, and it requires some code. So this is one of those things, if you just want to enable the system, you can check a box, you'll have it enabled for your app. However, if you do want to reload, for example, hide it, for example, that will require some scripting. And so if you're not sure how to do scripting, for example, with Unity, first, learn C# if you don't know it. And then second, Unity has great resources as well that cover scripting. And then naturally, take a browse through the documentation that we have for MRTK to learn more how to do that. So another demo in my office. Now that my office has been mapped, I have the controller in my hand, which not only has the button script, it has a grid object collection script, the controller, which is the white surface, the platform, the base, I think I called it itself, has that object manipulator script included with it. So now I can actually grab it. And what we're going to be able to view in this particular part of this demo is the cube. Once my space has been mapped, I'm gonna drop that cube into my scene. And the reason why I did this, just in case you're wondering why I have that as an option, is the fact that I need to map my space first. If my space isn't mapped and I start the app, the objects are just gonna fall. They're going to fall into nothing. And so you want to ensure that they're not in your scene just yet. Just give it a moment, map, and then you're going to go ahead and bring it into your scene, whichever way makes sense for your particular app. I've seen different apps that provide indicator cues of all the areas that need to be mapped, and there'll be arrows, for example. And then once the app is complete with, or once it senses that it's complete with mapping, then scenes can start, for example. So there's multiple ways to do it. This just happens to be the way that I did it. So let's go ahead and check that out. Here's my cube. It's on my floor. It knows my floor is there. And then from there, I can go forward, for example, and it just moved forward. I can move it to the right or the left, and then I can go back. What I'm going to do right now is back it even more into my bookcase to give you an idea of the fact that it knows my bookcase is there. So going on back near my skates, the controller kind of left me for a second. And as I get a little closer, because I want to get in on that side so you can see, I'm going to knock that cube against my bookcase because first, I think it looks cool, but second, to give you an idea of that, it knows it's there. So as I back it, it just hits the bookcase. Now, when I decided to go forward a little bit, just in case you missed that, you're going to notice it falls. It falls because that's an area of my office I hadn't mapped. So if you weren't necessarily sure what I mean by it falls into the nothingness, that's exactly what happens with unmapped areas. All right, so deploying to an Oculus. It's something whenever I happen to be doing VR development, it doesn't have to be an Oculus, but I also like to use the Mixed Reality Toolkit in addition to that. And so with that said, you will need to do some import. You'll need to import the Mixed Reality Toolkit Foundation package. You're also going to use Unity's SDK pipeline, as well as the Oculus integration Unity package. So the XR SDK pipeline, it will enable the Oculus touch controllers and the head tracking for your Quest. The Oculus integration Unity package is going to allow the use of hand tracking. If you're not familiar, Oculus Quest does have the ability for you to use your hands for interacting. And then for the MRTK, you can use the features that I shared here today with you all. Spatial awareness, probably not something that you'll use with VR, but the other UX features that are available, you can utilize from MRTK. And so one particular feature that I want to call out is the teleport system. You can also use that to teleport in your app as well with your controller. And so we're going to take a look at that particular one, an example. But the toolkit itself, again, available for both Unity as well as Unreal. But you're going to go somewhere different outside of the mixed reality feature tool to download that package. But you can use it with Unreal. We also have some tutorials over on Docs that'll actually give you an idea of how to use it. I believe it's a chessboard or a game board. I think it's a chessboard that'll take you through the steps of ways you can use it with Unreal, so you can learn more about that. So in this example, what I am going to do before I press play, just to set the stage, I was putting together an example of a museum exhibit. I'm obsessed with museums. And what I've done here, I have the actual model, thanks to the Smithsonian 3D project they have, of Neil Armstrong's astronaut suit, or his space suit, if you will. Now for this particular app, I did bring in some of our Azure services. Alex so kindly mentioned earlier that you can integrate those into your app. But the one I brought in here is from our Azure Cognitive Services. And so I utilize the text-to-speech. So that way, what happens in this particular demo, we won't be able to hear it, but just so you're aware of what's happening. When someone presses one of the language buttons, again, MRTK buttons, it's actually going to play back what I have here on in this written part on this slate of what's there, but in the respective language. So if you're curious to learn more about how I set that up, definitely follow up with me on Twitter, for example, and I can give you more information about how to do that. But that's what's happening in here. So let's go ahead and play that. So this is what it looks like. I'm pressing, I think I pressed English, for example. So again, you can't hear it, but it's playing in English. And then over on the left, I'm using teleport. So boop, got closer. And because I have Object Manipulator on Neil Armstrong's gloves, I'm able to pick those up, move them around, and then I can just place them back here on this particular makeshift podium, if you will. So I created this. Why? Because how often do you get a chance to go to museums and actually pick up everything? I like touching everything. So that's why I created this example, especially for those of you who are wondering how you can bring more educational experiences into VR. As an example, you're able to do things like this with the Mixed Reality Toolkit. So, Stereo Kit. So for those of you who'd rather do a little more with coding, maybe you don't want to necessarily learn a new engine, for example, like Unity or Unreal. Maybe JavaScript isn't your thing, so you might not want to use Babylon.js, for example. There is an option for those who do just want to do things native. You have C# that's available alongside Visual Studio. So I personally started utilizing StereoKit more so this year. It is another mixed reality development option. And so StereoKit was developed by our very own Nick Klingon-Smith here at Microsoft over in the mixed reality team. It's an open source mixed reality library for building HoloLens and VR apps with C# and OpenXR. And so rather than download an engine and its required dependencies, you can do your programming directly in Visual Studio. Furthermore, you can deploy your app in seconds instead of minutes. So we're going to check out how to get started with StereoKit. Also, I hear a very great person named April Speight created the intro videos for StereoKit as well. So if you are curious to learn more and want more of a video view of how to get started, let me know. So starting with the project setup, you will need to download and install the required software. If you prefer to develop for desktop, you're going to need Visual Studio 2019 or the brand new 2022, and then the .NET desktop workload. If you prefer to develop for HoloLens, as an example, then you'll need the Universal Windows Platform workload instead. Now, there's also StereoKit templates available in the Visual Studio Marketplace, and they can be used to get started with your project. Alternatively, you also have the option, I should say, to add StereoKit to an existing project using the StereoKit NuGet package. So very quick little demo, but from here, I'm creating a new project, I'm selecting the template, and what we're going to have a chance to take a look at next is what we're going to see in Visual Studio. So setup is a little less than what I went over with Unity, for example. So there's just something to think about. So here in Visual Studio, on the right in the Solution Explorer, I do have the what's in the template itself. So I have a dependencies folder, I have an assets folder, and then I have this script called program.cs. This is literally what you get when you add, when you use the template itself. So these things are already set up. That assets folder is going to be very important because that's where you can put your assets, your models, materials, what have you. And then that program.cs script is where we're actually going to have our app logic. And so we do give you, or I should say Nick gives you some sample code there that it loads a cube and then you can move it around. So in here, on the left-hand side is that program.cs script. Very short, I will say. Again, what this does is it starts to initializes the project. If I back up a little bit, around the top half is where you can assign the project name. You identify the assets folder as well. And then in addition to that, moving on along, this is where I can then create the instance of the model. So starting, oops, sorry about that, everyone. Starting with the create assets used by the app. It's kind of in that middle area. That's where we are creating that model. And then down below, this is now where we are going to start to draw that particular model. Now, I have an example of just an actual model, not just a cube that StereoKit renders. And so in terms of the flow of how this works, what you're going to do, in this case, it's just 3 steps. First, you'll initialize StereoKit, as I mentioned, and then from there, you're going to create the model itself. So you can set the location, for example, there, and any other settings that you want to include. The supported file formats are going to be OBJ, STL, GLTF, and GLB. And so again, that assets folder is where you're going to have your models. And then finally, you're going to draw it. And so the model is drawn every step of the application. The app steps each frame until StereoKit is told to exit. And also a callback is called every frame, after input and system events, but before draw events. So on the right, I have a flight helmet that I rendered with StereoKit as seen through a HoloLens. And I'm able to grab it. StereoKit gives me hands. And there we are. I'm able to move it around. So another option for those of you who might want to try with StereoKit instead. So again, this is that code that I was just explaining more so, but just to give you a visual of pretty much how much code that involves. It's very few lines. And also, if you like looking at code, I added it here for that group of folks as well. So in addition, there's more than just the simplicity of a model that I loaded as examples. There's 2 very great projects that are provided at StereoKit.net that I'd suggest checking out. The first on the left is going to be StereoKit Paint. It's an app that gives you a color palette to paint the world around you. And so the project, it's a great example of how you can create and use custom and standard UI, line rendering, file save and load, and hand menus. And then finally on the right, we have the Bing Maps API and terrain project. So that's going to load and display satellite imagery and elevation information from the Bing Maps API, one of our APIs. And this project, it's a great example for showcasing how to use StereoKit's shader API, load color, height, data from an external API, and then build a pedestal interface with the content. So if you really want to get an idea of all the different features you can use with StereoKit, check out the sample project. There's a repo that'll point you to where you can grab the code for that. And so I believe we're at an end, everyone. So I have resources available here. The folks at the Reactor were so kind to bring them all together for you all. So you don't have to rush to go write everything down right now or take a screenshot. Make sure you did register for the event. You'll be able to get links to what we have here. There is a StereoKit hackathon going on. This is the final week, but we encourage you to join if you're interested. And then I'm on Twitter as well as LinkedIn. So thank you, everyone. I know that was a nice, fun little crash course, but Alex, I will turn things back over to you.
Awesome. Thank you so much, April. That was such a cool intro into mixed reality development. I think, you know, when you're getting started, sometimes you're not sure where to look, what tools are available. And so it's good to see, you know, not just on Unity, but on Unreal and with StereoKit that you're able to use lots of different tools, and we're effectively meeting you where you are with the different kind of tool sets that we have. So it's super, super cool. So I in terms of, you know, April, you kind of mentioned it as well. It's really important to check into the event today if you haven't already. What you're able to do when you check in and use the QR code here is you're able to actually get all of the resources after the session. So unless it's just a heads up, just by registering, you don't do that. So if you check in, you'll get all of the resources and information that you can get after the session. So please use that QR code that's on screen right now to check in, and you'll be able to get all of the resources and information afterwards. Awesome. So moving on to the kind of next speaker, April has provided an amazing overview of MRTK, of Unity and StereoKit and all the different tools. What I wanted to do next was to bring in a speaker to talk about, okay, once you've learned the basics of mixed reality development, what if you want to go a little bit further? Maybe you want to go a bit crazy with hand interactions and stuff like that. So I'd like to welcome Oscar in at this point to give a little bit of an intro into to his session. And Oscar, over to you.
Hi, thanks, Alex, and thank you for having me, everyone. I've actually cheated a little bit today, and I've pre-recorded my talk just to make sure that I explain everything correctly with all the details and everything. But I'll be around for questions after, and I've actually worn the same T-shirt just so it'll be totally seamless. Don't worry, you won't even notice. Cool. All right. Enjoy. Hi, welcome to Touching Holograms. This is a project about designing more physical interactions with holograms. So who am I? My name is Oscar Salandin. I'm a technical designer and technical artist at Mixed Reality Studios, Lighthouse, London. My background is that I trained as an industrial designer at university, and I also spent a short time working as an industrial designer in Connected Play in Microsoft Research. I spent some time doing UX design for Windows Phone apps, and for the last 5 years, since 2016, I've been working on HoloLens and other mixed reality projects inside services.
Sorry, everybody, we had a bit of technical difficulty, but we will be right back. Meanwhile, please check into the event if you haven't already done so. I will just sort out the video and we'll be right back.
Hi, welcome to Touching Holograms. This is a project about designing more physical interactions with holograms. So who am I? My name is Oscar Salandin. I'm a technical designer and technical artist at Mixed Reality Studios, Lighthouse, London. My background is that I trained as an industrial designer at university, and I also spent a short time working as an industrial designer in connected play in Microsoft Research. I spent some time doing UX design for Windows Phone apps, and for the last 5 years, since 2016, I've been working on HoloLens and other mixed reality projects inside services. Today I'm going to talk about the inspiration for this project, then talk about some of the prototyping and iteration that went into it. I can show some of the live projects that are using the hand physics touching holograms toolkit, as well as talking about some of the future work where I'd like to take this project. So first I can talk about some of the inspiration for this project. I went to an event called Train the Trainer over in Redmond, and I saw two talks, one from Sophie Stelmark about the eye gaze interactions, and one from Julia Schwartz about hand interactions. So I found this all very inspiring. This was the first time I got to use a HoloLens 2, and it was really exciting to have all of the new inputs, especially coming from HoloLens 1, where we just had, of course, the head position and an air tap and voice and things like that. So I was really excited by all these much more direct and kind of high frequency inputs as well. However, one thing that I noticed about these interactions, which certainly makes them more easy to pick up, but also makes them perhaps a little bit limited, is that they're largely based around kind of this metaphor of a kind of a 3D mouse. So there's a kind of one position in particular for your pointer, which is on your hand. I know you've got two hands, but each one is kind of a pointer, and it's also got a kind of binary state between press and not press. And it's also got a 3D position. So in many ways, it's very analogous to a mouse, which I think makes it very easy to pick up, but also is not how objects behave in the real world. So in the real world, objects have a physicality to them, and you can hold them in various ways. And we've learned all our lives how to interact with these things in a slightly more complex way that leaves a lot of open-endedness for interactions as well, beyond moving things, clicking things, and dragging them around. So this is a top-down approach where the interaction outcomes have already been decided, and the actions of kind of tapping and clicking and moving have been all designed in order to get those particular outputs. So I was interested to find out, could we use a more unconstrained approach for more creative scenarios and allow a little bit more freedom for the user as well. My inspiration here was physical products. As I mentioned earlier, my background is in industrial design, so thinking a lot about how things feel in your hand and creating the affordances for things to be picked up and moved. And I find something just very satisfying in the kind of everyday motion of objects, and something that you've got like a phone or anything else, you can kind of play with it, even though it's not designed to be played with, but you can twiddle it in your fingers or you can flip it around, etc. And all of that just kind of, for me, brings a more delightful interaction, even though these are just pretty inanimate objects. So the question I was asking here was, can we bring some of this joy and the satisfaction into mixed reality interactions as well? Okay, so some of the prototyping and iteration that went into the Touching Holograms project. So this is some footage from the event Train the Trainer. Pretty much as soon as I got my hands on a HoloLens 2, and having seen the talks from Julia and Sophie, I had an idea of what I would want to do with it. And the first thing I wanted to do was to try just putting some simple spheres onto the hand joints that's new input that we had, and see what happens if we have some physical objects. To be honest, I was very surprised that it worked well. I thought it was going to take a lot of iteration to get to this point, but it really just there was a lot that you could do with this, and taking these objects like a board and a ball was just, for some reason, very fun. And I think the gravity was disabled as well, just so that things didn't fall past the spatial mesh all the way off to infinity. But then having a zero gravity object itself was quite fun, because I've never had that before here on Earth. So just throwing things around, watching them float in midair, and kind of feeling that feeling of what it'd be like to be on a spaceship was kind of fun as well. It also gave me an idea of, this board could be a piece of UI. We could leave this floating in the environment. We could push it out of the way if it became in the way, rather than having to think about where can I grab this object, do a grab gesture and so on. You could just sort of shove it out of the way. That to me was really interesting as well. So what worked here was that it was surprisingly stable, even with that thin board object, which I thought it would have some difficulty with. However, when turning an object or moving one of them, it quickly fell out of the hand. Another problem was that releasing objects caused them to move or float away. So it was very difficult to leave something exactly where it was. Also, grasping larger objects became more difficult. Now that we're dealing with these objects in a physical way, we start to have some of the physical problems of how do you grab a large object. A dog can't bite a beach ball, and I can't move a fridge with one hand without a handle. So the next prototype was about how to move objects. Now that we've got these physical problems, we can look to physical solutions. So in the real world, to open a door, I add a handle to it. There's a number of different types of handles, so I wanted to try some of these out. There's a kind of a cube-shaped one here where it allows a lot of leverage to be able to twist something. There's also a kind of a graspy one, but that proved quite thin, and the hand spheres could kind of fall through that. And there's a sort of more of a knob and a kind of a shelf one as well. I really like the shelf one because it was very difficult for it to slip out of your hand, and you also had a lot of leverage to move it around as well. Another problem here was that using only the hand joints that are provided by the API, there's a lot of gaps really. So the hand is made from these spheres, but each sphere, but particularly between the knuckle and the first joint there was a lot of gaps. So with a smaller object like this one I kind of thought is about the size of a phone, and I was thinking like maybe we could have some kind of phone UI on one of these. Haven't got to that yet, but it's relatively small in terms of like a hologram and the physics system, but it's a quite normal sized object to be able to interact with. But it was having a lot of problems here because it could slip all the way through without touching at all. What I decided to do to improve this was to interpolate between some of these joints to fill in some of the gaps. So the positions are just interpolated between the joints, and that way we get a more solid representation of a hand. This is also similar to a lot of the soft body simulations and how those work in physics systems. And essentially, I want my hand in this simulation to be a soft body, because if it's too rigid and the tracking goes a little bit, then the objects are just going to fly all over the place. So it needed to be soft. Some other things that I added were, you can see on the lower one, is a kind of a ghost mode of the hand through the object, just so that you could see what your fingers, your virtual fingers, were doing behind the object and understand more about how you are actually grasping the object. So I thought it was pretty impressive that with this improvement, I went from not being able to hold the phone properly to being able to sort of twiddle it in between my fingers, although slightly clumsily, but still better than I expected to be able to do. I think this is an example of the kind of interaction which I never designed for. I didn't say I'd like to have something where I can twiddle it, but once you've got it in your hands, you start thinking about, can I do this? And those kind of bottom-up interactions just emerge out of it. Another problem by bringing physicality into holograms, now especially having added gravity, is that gravity is pretty unforgiving. So if something falls, it falls down onto the floor. I now have to bend down and pick it up. It falls down pretty quickly, so I miss it. You can see in this video I knocked other things off as well. It's all a bit of a shambles, really. So the obvious thing was to go, well, what if we don't have any gravity? And that's what's in this lower video. But then you have the problem, you put an object down and it doesn't stay down, and it'll just drift away. The same problem is what astronauts face on the International Space Station. And it's why they have Velcro everywhere. to just keep objects pinned to surfaces as well. One option for this could have been to just increase the drag on the objects so that they naturally slow down. But when you've got all this drag and you're trying to move something quickly, it's resisting all that movement, and then that just feels very unnatural in the interaction. So this is a problem I really wanted to solve in a different way. The solution I came up with for this problem was called surface gravity. So here, what's happening is that each object is understanding, does it have somewhere to fall onto? We want gravity to affect these objects, but the problem arose when these objects fell too far onto the floor. So each one of these objects is looking to see if there's a surface below it that it can fall onto. And if so, it applies the gravity to itself. And if not, then it just kind of hangs in the air. So you can see here, as this tower is falling down, the objects fall, but as they come off of the surface, they just float there. And this means that you can just pick them up and put them back. And this is much more forgiving to mistakes because, of course, this hand interaction system is not perfect, and it's not as fast as interacting with a normal object. So you can't just grab things. It doesn't have the same feedback as well. So it's more prone to mistakes and errors than interacting with a physical object. Another way to make this more forgiving was to apply less gravity so that all of the objects move slower and these kind of mistakes can happen slower. So here, this is half of the Earth's gravity, and that kind of compensates for some of the mistakes and some of the latency in the hand tracking as well. Another problem, this is actually from the very first prototype here, is Faraway Objects. This is my colleague Jose, who's just thrown this ball up into the air, and he just about got it down. I've also seen people standing on, another colleague stood on a bar stool in order to try and reach something. I had to say, maybe don't do that. I don't want it to be my fault that you've fallen off and broken your wrist or whatever. Yeah, I think being able to reach these objects when there's no gravity, or there's no particular way to get to it. We had other people throwing another object at the object to bounce it down, but then they got that object stuck up in the air. Other people bouncing it off the ceiling and then getting it down. There's a lot of just emergent things that can happen there, which is fun, but also can be quite frustrating. So these are interactions that we want to avoid having. And on the right here, this is dropping a sphere. It kind of rolls away, and then it goes under a table, under a chair. Another one goes kind of behind the bin. Searching around for these objects, maybe this could be a fun mini game somewhere, but it's not kind of the interaction that you want to be doing all the time, every day. And so the gravity has helped with this, but I think there's more that we can do to help with this problem of faraway objects. So the solution that I came up with for this is telekinesis. So it's not a thing that exists in the real world, so maybe it's not a natural interaction, but it is something that pretty much everyone, I reckon, has at least pretended to do when they're a child. I think it's quite common in, and I looked particularly at Marvel films and other films like Star Wars and Matilda, and I think Magneto has a lot of this stuff going on, where there's a common thing that grabbing an object like that with an open hand is to sort of hold it in midair. And so in this first version, all that happens is you hold your hand up and there's a kind of a gesture confidence, and that gesture confidence starts applying force to the object as well, and it brings it towards the user's palm. Another thing that's worth saying about this is that you need to know which object to move. So for this, I've used the HoloLens 2's eye gaze tracking in order to select one of the objects. So here, even without moving your head, the hand gesture brings the object close, but it'll select which object to bring close using your eyes. And even in a kind of crowded set like this, you can bring it close. And I think even one of them has, one of these cubes is actually behind the other one, but if you're looking at it specifically, you can still bring it out past that other cube. So here we go. It does knock the other one out of the way though. So this is kind of just a collection of other ideas that I had at the end of the first short prototyping sprint. So interaction with a kind of virtual tablet, maybe it's a large screen and you can tap it, but it's something you can hold and move around. I've also got a ragdoll there of myself, which we scanned and rigged up. We've got the classic sort of lightsaber, pulling a lightsaber towards you with some bad blending on the blade, unfortunately. But yeah, Joe doesn't look too happy about that either. And then in the top right, this is kind of using objects to move other objects. Again, I didn't program in anything specifically for this. It was just something that emerged from having a physics system with the hands, but you can pick up an object and now you're using that as a tool to influence another object as well. I think one of the things I like about this is just how natural all of the animations look as well. And something silly like that I just decided to do looks in some ways quite realistic. So one of the next things that I added to this was lighting. I've been looking at a lot of shading for another project, and I was interested to see how could we improve the physicality of this by having some lighting. So what you're seeing here is essentially a point light inside each one of these cubes. It lights up when you touch it. It kind of animates towards a glow. And then the other thing is using the hand mesh that you get as standard. So I added a shader to this that uses a point light and also has some kind of PBR shading to get the right kind of sort of reflectance on your hand, and also a little bit of subsurface scattering. So some of the light can actually, especially when it's very bright, can come through the hand and gets colored a little bit reddish orange from the insides of your hands. And all of this, I think originally I just wanted to do this because I thought it'd be cool and it'd look interesting, but it really added a lot of useful information for the interaction. So now you can understand, like, how close is this object to my hand, and is it behind my hand or not? Like the depth, which although you've got binocular vision, is still a little bit difficult to work out. A lot of this actually then starts coming from the lighting information. And when you have this an object on the table, you can see that it is on the table because of the glow around it as well. So yeah, I was just really pleased with this because it was a bit of a happy accident, and it just turned out a lot better than I ever expected it to. And I really felt like this was the first time, like with this new lighting, that I actually felt like I was sort of touching a hologram and felt like I held it, like not literally tactile feeling, but it went up a step by adding this for sure. Over here, this is some more work that I did on telekinesis, so knocking over an object and bringing it back with telekinesis. Here, we're looking at some other ways of doing the gesture for it, using like an open palm gesture to bring it towards your hand. So this work was really looking at how can I control an object at a distance, not just summon it towards me. Previously, you open your hand and it's summoned towards you. But maybe you want to use that open hand gesture here to move it at a distance rather than actually to summon it towards you. So I started experimenting with like an open hand palm up gesture, maybe to bring it towards you. So you can hold them at a distance to manipulate them. And then you turn your hand over here and it comes towards you. This is just, I asked a few different people, like, if you had an object at a distance, what would you do to summon it towards you? And I did get some mixed answers between sort of things like open palm, as we had before. Some people said open palm up, which is what inspired this. Other people said a sort of a coaxing gesture, which to me seemed a little bit, it seemed like it would probably be detect that gesture and then animation happens rather than a kind of something you have control of as you're doing it. I really liked the way that I was really pleased by how the gestures flow into one another in this, and they're not just do a gesture and then action is performed. Also using the lighting here to distinguish between which hand is controlling which object. So here I can talk about some of the live projects that are using this code and this system. Something I've been looking into recently is using more complex physics simulations. So using the same hand physics Toolkit, but also combining it with some cloth simulations and some soft body simulations as well. We're looking into some digital fashion industries at the moment, and in particular, people want to be able to see what the material properties are of one of these pieces of fabric. This is just an example where it's a sheet on its own, but I think one of the next things I'll be making is maybe a t-shirt or a full costume or a full outfit made of this material. Maybe we'll have it on a mannequin. Maybe that mannequin can be sort of walking around, or maybe there's a mannequin opposite you and you are the mannequin playing around. But there's lots of possibilities here. So one of the ways I thought the hand physics system could be used before would be to kind of see a virtual product, so I can pick it up and hold it and stuff like that. Of course, with an industrial design background, I was initially thinking about kind of solid, hard surface objects, but I think this could absolutely apply to digital fashion and to soft objects as well. This is a kind of a squishy dough ball object, which is probably far too squishy for what I actually wanted. I wanted more of a foam, but I ended up with this and couldn't stop playing with it. So this kind of bounces around as a bit like a kind of pizza dough or something, but gel. There's just something about all of these simulations where you can try things out and so what happens if I squish it with my hand? I just find that very delightful and playful as well. So looking into the future, I think there's a lot of possibilities here. As I say, industrial design background, I keep thinking about what if this physical thing, but it's a hologram. And I think one of the things that really interests me is how can we make something that is familiar and versatile, like a physical object, but how can we also bend the rules so that it and make the most out of the virtual space? So in the same way that before we could pull objects with telekinesis to kind of bend the rules a little bit, and the surface gravity also bends the rules. Maybe we've got something, there's a vinyl player there. Maybe we've got something where there's a physical object, whether it's a vinyl or a tape or a weird sphere that you can sort of listen to. And maybe a music player then is something you can throw at it. Or what if we've got a Rubik's Cube, but it's something more interactive that kind of powers itself, and it can turn around and light up and transform in some way that wouldn't be necessarily physically possible. I'm also interested in how data can work for. I mean, as I say, with the music example, but what if that is our other files, and what if I just go like some gesture for taking a photo, and then I've got a physical simulation of a photo, and maybe I can hand that to people, maybe I can send it to people, put it in a post box. This whole kind of tangible digital interaction is something I'm particularly interested in. But the overall question for me is how can we make these virtual products, these virtual experiences feel much more physical? And for me, I think a step in the right direction would be to go with some sort of physical simulation to allow these objects to behave in a way that is familiar to us and is flexible as well. Okay, I think that's about it really. So thank you for watching this video, for seeing this presentation. And if you want to check out any of this article or any other work of mine, then feel free to go to my website. It's just oscarsalandin.com.
Awesome, cool. Yeah, that was a really awesome session, Oscar. Really appreciate you sending us that video. It's such a cool thing to kind of, I think, and this is what I was really happy about this session, was that we had, the start, which was, an intro from myself, then going into like, how do we get started with mixed reality development, and then kind of going into the kind of next steps regarding, what can be achieved with all this kind of stuff. So really cool. I was going to say, Rav, can you bring in April back into the conversation as well? Because it'd be really good to kind of jump into some questions. I know we've had a lot. Adam's here. Awesome. Adam, I was going to say, could you maybe do a little bit of a wrap up, and then we'll just jump into some questions. That'd be awesome.
Yeah, I'll be super quick. And yeah, thanks very much. And sorry, that was my fault that the video kept stopping. My browser keeps crashing this evening, so thanks for bearing with. I just want to mention quickly about a Microsoft Learn platform. All of the things that we've covered today on this call are available inside Microsoft Learn. So we've put a link on the screen, aka.ms/MRDev forum. There's also a QR code here that you can scan, and if I come back, it's the same QR code behind me. Microsoft Learn is our learning platform, so do check it out. Go to the link. I won't do a demo I was going to do because we are tight on time, and I feel like we should just jump straight into the questions. Because my browser's crashed, I don't have the questions in front of me anymore, so I'm going to just jump straight into the ones that have been asked by our public, if that's all right. And the first one that I can see was from Savio Fernandez, which I think, Alex, is probably really for you, which is, can you please share a few use cases where augmented reality and mixed reality has customer real-life scenarios?
Absolutely. So I guess that's a really interesting question, because if you remember back to about an hour and a half ago when I was doing my slides, I've obviously been a customer of this technology at McLaren, both in automotive and Formula One. So if we talk about automotive use cases or manufacturing use cases, if you imagine it's your first day on the job and you're not sure what you're supposed to be doing in terms of the assembly of a piece of equipment, usually you would go into a classroom and learn about things. Maybe you're given a stack of paper of things to learn. Well, how much more immersive and how much more better as a learning path would it be to put on a device like a HoloLens and actually be guided step by step through what you need to do to resolve that task? So actually seeing the screw holograms going into the physical item, going through and actually talking you through things and then tracking that. So I mean, there's millions and millions of use cases, both in healthcare and education as well, in terms of visualization. As you can imagine, any use case where seeing 3D content in an immersive way, is a real value add. But if I was to call out one, based on my experience at, in automotive and Formula One, I'd say guided task execution, be able to go step by step through a task and seeing it in 3D with a hologram would probably be one use case that I really enjoy. And every time I try software that's able to do that, it's just, to me, it still blows my mind. It's pretty cool.
Thanks very much. The next question's for April, which is actually, how did you personally get started with mixed reality development?
Say that one more time.
How did you personally get started with mixed reality development? Oh, April, you've gone on mute.
Yes, if you want to get started, we have some resources available in our resources section of what you can go through our learning paths. In addition to that, we also, you're using Windows Mixed Reality Development. We have a page that provides the tools that you do need to have installed to get started, but I'd suggest going to Microsoft Learn. We have a fabulous HoloLens 2 fundamentals path. You don't need a device. It more so shows you how to get started with what we have here with MRTK and Unity.
That's absolutely amazing. And we'll put the link up, and you can use this link, aka.ms/MRDev forum, for all of the links, and also the reactor will send out if you checked in at the start. Oscar, I've got a question for you, and I'm also going to put your website back up because it didn't show at the end of your video. But do you have any advice for people starting a career in mixed reality, or switching from, for example, a career in gaming into immersive technology?
I'd say to just try and make something would be my first bit of advice. So I guess following either some of the tutorials online or some of the stuff that April's just mentioned. But you can, if you don't have like a HoloLens device, you can either use the emulator or just the Unity editor itself. I'd recommend Unity. I've been using it for years and it's great. And yeah, if you're a game developer, then you'll know this too. But you can just use, like, any phone these days has AR Core or AR Kit. And you can do AR at home with the equipment that you already have. So I'd say just make something, play with physics. Physics is fun and things happen by using that without too much programming. And April's demo also uses physics. So like, it's a good way to make things move in an interesting way and have a play around to begin with. So yeah, I'd say just make something and video everything that you make so that you can look back on it as well.
Amazing. Right, final question, quick fire. You're going to have to answer this very quickly. What's everyone's favorite VR video game? Going to Alex first.
Well, I plugged super hot on in my slides. I say that, yeah, just the ability of having people attacking you in VR is still scary to me. But yeah, that'd be super hot.
April.
Richie's Plank. It's fun until you get into scary mode, but it's good.
And Oscar.
I was going to say super hot as well, but I'm just going to go really mainstream and say Beat Saber.
Amazing. Thank you so much, everyone. We are unfortunately out of time. We wanted to answer far more questions. I think we'll try and answer some in the chat. Just if anyone wants to stay on the chat, we'll try and reply to you in there. Thank you so much to everyone for joining. It's been a fantastic. I thoroughly enjoyed it. I learned a lot today. Apologies for the brief interruption to the video there. But please join us again for another Reactor event very soon, and make sure you click on scan the QR code or click on the link to get all of the event resources. Thank you so much again, everyone, for joining.
Cheers, everyone.
Thanks a lot. Bye-bye.